All right, so once again, we are solving compound inequalities. We have another OR one, so I'm going to do this one here on the left. All right, and so here it is 8x minus 4 is greater than 7 plus 8x. Now, notice here that I have, I'll show you in green, two 8x's like this. So this means it's probably going to be either no solution or all real numbers. And we'll kind of have to see based on how we solve it out. Now in this case, I would do minus 8x, and I would get negative 4 is greater than 7. Now in this case, this is a false statement. Negative 4 is not bigger than 7. So false. So therefore, this is no solution, just for the part in blue. But I got to check my other half here in green. And here I have 9x minus 5 is greater than 10x minus 6. Now notice in this case, my x's are different, all right? So we are going to get an x value in this case. So I want to solve for that x. I do minus 10x minus 10x. That cancels, excuse me, negative x minus 5 is greater than negative 6. Add 5, that cancels. Negative x is greater than negative 1. Divide by negative 1, divide by negative 1. And this becomes x is less than 1. Now, the key here is this is an OR statement. All right? So if I were to graph the problem here in blue on the left, it would be no solution. I wouldn't put anything on my graph. But I have graph here on the right, x is less than 1. So in green, x is less than 1. I have open circle here and is less than 1. And this is my solution. I would actually draw this in. Because it's an OR, I can take the solution from either one of these statements, basically to make this true, any value less than 1. So I do actually have to graph it in because it is an OR statement. If it was an AND statement, it would be no solution because we would have no overlap. But in this case, we don't need overlap. We just need one of the two inequalities to be there for it to be true or valid. And so in this case, our green inequality is our graph.